Hello guys! Today we will talk about robot and other motion control systems. This presentation is brought to you by Tabiosas, Alalud, and Chavez. Subtopics. We will talk about robot concept, mechanical configuration, and categories of software for industrial robots. First, let's talk about robot, the concept of robots. What are robots? Robots are man-made machines that can perform work or other tasks, either automatically or by remote human control. It is also defined as a type of automated machine that can execute specific tasks with little or no human intervention and with speed and precision. Moreover, it is also defined as man-made mechanical devices that can move by themselves, whose motion must be modeled, planned, sensed, actuated, and controlled, and whose motion behavior can be influenced by programming. Robotics. Robotics is the science and study of robots. It is an interdisciplinary sector of science and engineering dedicated to the design, construction, and the use of mechanical robots. What is motion control systems? At the most fundamental level, a motion control system is any system that controls the energy flow to generate mechanical motion with some desired properties. So the earliest example was the flyball governor developed in 1780s. This control system for Watt steam engine used the centrifugal forces of the balls to set a throttle angle and main constant engine speed. While flyball governor is purely mechanical control system, modern-day motion control systems typically convert electrical power to mechanical motion with an electric motor, and do so under the supervision of a computer. Now let's talk about the history of robots. In 1920, the word robot was invented by Karl Kapek. The word robot comes from the Czech word robota, which means forced work or labor. So, Karl Kapek. So, in 1920, the word robot first appeared in the drama written by Karl Kapek. The name of the drama is RUR, RUR, abbreviation for Rossum's Universal Robots, a company which plays a prominent role in the story. Robotics. So the word robotics was first used in Rand Around, a short story published in 1942 by Isaac Asimov. Isaac Asimov also proposed these three laws of robotics, and he after added a zeroth law. So let's define it further, these laws. So the three laws of robotics. First, the zeroth law. A robot may not injure humanity or through inaction allow humanity to come to harm. First law. A robot may not injure a human through action or inaction allow human being to come to harm, unless this would violate a higher order law. The second law. A robot must obey orders given it by human beings, except where such orders would conflict with higher order law. And lastly, the third law. A robot must protect its own existence as long as such protection does not conflict with the higher order law. In 1956, the real robot came into existence. 1956, George Devol and Joseph Engelberger formed the first robot company. After the technology explosion during World War II in 1956, George C. Devol and Norman Schaeffler and Joseph F. Engelberger made a serious and commercial effort to produce a robot. They started a firm named Unimation and succeeded in building the first robot named Unimate. So the first robot company is the Unimation. Now, in this picture, you could see George C. Devol in the right and Joseph F. Engelberger. are served by a mechanical arm they developed. Now, and did you know that Joseph F. Engelberger is also known as the father of robotics? Hmm. Now let's talk about the first the first industrial robot, the Unimate. So in 1959, the first robot prototype was developed, the Unimate number 1. It was the first used in General Motors. It is basically to extract die casting from die casting machines and to perform spot welding on auto bodies, both tasks that being particularly hateful jobs for people. A variety of other tasks were also performed by robots, such as loading and unloading machine tools. The Unimate started a revolution in robotics industry, and many robots of its type were built for doing tiresome jobs for people. Robots offer specific benefits to workers and industries. If introduced correctly, industrial robots can improve the quality of life by freeing workers from dirty, boring, dangerous, and heavy labor. So in 1961, the Unimate 1900 series became the first mass-produced robotic arm for factory automation. Mindful of the uphill battle he would face from the manufacturers and motivated by Asimov's three laws of robotics that relate to the first do no harm philosophy similar to Hippocratic Oath, Engelberger focused on employing the robots in tasks harmful to humans. This strategy worked, and in 1959, the 2,700-pound Unimate number 1 prototype was installed on the assembly line for the first time at General Motors die casting plant in Trenton, New Jersey. By 1961, the Unimate 1900 series became the first mass-produced robotic arm for factory automation. In a very short period of time, approximately 450 Unimate robotics arms were employed in die casting. So here's the picture of Unimate. Now let's talk about the common types of robots. We have the autonomous mobile robots, AMRs, and automated guided vehicles, AGVs, articulated robots, humanoids, cobots, and hybrids. So this is what the autonomous mobile robots looks like, AMRs. So AMRs move throughout the world and make decisions in real times as they go. Technologies such as sensors and cameras help them ingest information about their surroundings. Onboard processing equipment help them analyze it and make an informed decision, whether that's moving to avoid an ongoing worker, picking precisely the right parcel, or selecting an appropriate surface to disinfect. They're mobile solutions that require limited human input to do their job. Now let's talk about automated guided vehicles. So this is what they look like. AGVs. AGVs are defined with this. While AMRs traverse environments freely, ang mga AGVs naman is rely on tracks or predefined paths and often required operator to oversight. These are commonly used to deliver materials and move items in controlled environments such as warehouses and factory floors. Wait. Like this, makita nyo ang line niya black. So, ang GVS rely sa tracks and predefined paths. Now, let's talk about articulated robots. So, articulated robots are also known as robotic arms, are meant to emulate the function of a human arm. Typically, this can feature anywhere from 2 to 10 rotary joints. Each additional joint or axis allows for a greater degree of motion, making this ideal for arc welding, material handling, machine tending, and packaging. Now let's talk about humanoids. Here are the examples of humanoids: the THR-3, the Sophia, the SoftBank Robotics Social Humanoid, and Digit, a headless humanoid has nimble limbs that helps in uh, in their work. So yeah. So let's define humanoids. While many mobile humanoids robots may technically fall under the domain of an AMR, the term is used to identify robots that perform human-centric functions and often take human-like forms. They use many of the same technology components as AMRs to sense, plan, and act as they carry out tasks such as providing directions and offering concierge services. Now let's talk about cobots. So here's the cobots, and the definitions of cobots is collaborative robots or cobots are designed to function alongside or directly with humans. While most other types of robots perform their tasks independently or in strictly isolated work areas, cobots are shared spaces with workers to help them accomplish more. They're often used in eliminate manual, dangerous, or strenuous tasks from day-to-day workflows. In some cases, cobots can operate by responding to and learning from human movements. Now let's talk about hybrids. Hybrids. The various types of robots are often combined to create hybrid solutions that are capable of more complex tasks. For example, an AMR might be combined with a robotic arm to create a robot for handling packages inside a warehouse. As more functionality is combined into a single solution, compute capabilities are also consolidated. Now let's talk about the three main components of robots. We have the sensors, effectors, and the control systems or the brain of the robot. Let's talk about the sensors. Sensors allow a robot to gather information about its environment, which is used to guide its behavior. So, sensors like camera, microphones, thermometer, barometers. There are also sensors or that are more complex and can give more capabilities, such as the LiDAR or light detection and ranging. Sensor use lasers to construct 3D dimensional maps of their surroundings such as they navigate through the world. The cheaper way to achieve this same goal is the supersonic sensors, which only using high frequency sound instead of lasers. Sensors. Other types of sensors are more complex and give more capabilities. Some robots are with specialized sensors such as accelerometers and magnetometers that allows the robot to sense its movement with respect to the Earth's gravity and magnetic field. Now, let's talk about the second component of robots, effectors. Most are specific to tasks and that you want your robot to do. So here's the example. Mars rovers have tools like hammer, shovels, and a mass spectrometer to use in analyzing the soil of Mars. So these are the effectors. Effectors are the parts of the robot that do the work. So this is the part of the robot that do the work. Effectors are tools that you can mount on your robot and control with the robot's computer. Common effectors. We have end effectors, motors, and speakers. End effectors. Tools at the end of robotic arm and other robotic appendages that directly interact with objects in the world. A gripper at the end of a robotic arm is common end effector. Spikes, lights, hammer, and screwdrivers. Medical robots have their own specialized effectors such as tools for cutting in surgeries and suturing incisions. So, motors. Motors can use for many moving parts of a robot, from joints on robotic limbs to wheels on robotics vehicles to flaps and propellers on robotic airplane. Pneumatics and hydraulics are another way of moving parts of the robot, particularly where the robot needs a lot of strength to perform particular tasks. Speakers. Speakers can allow certain robots to talk to us or generate other sounds. Speech is, after all, a behavior intended to modify the environment, usually by conveying some sort of information to the people around us. Now let's talk about control systems. Control systems are the brains of the robot, the part of the robot that determines the robot's behavior. These regulate and command the functions of the robot in order to achieve desired results. So there are two kinds of control systems. We have pre-programmed robots and autonomous robots. In pre-programmed robots, very simplest programmed robots merely repeats the same operations over and over, while autonomous robots are more complex robots that are able to respond appropriately in the environment and that are much more complicated. Pre-programmed robots are insensitive to the changes in environment or can detect only very limited information about the very limited parts of environment. It will also require little in way of controls, but it will perform properly only if environment behaves in accord with the robot's pre-programmed actions. On the other side, autonomous robots have sensory apparatus that allow it to detect changing features of environment and a range of behaviors that will allow it to respond to those changes. Whatever feature of the robot enable it to adapt its behavior to its environment, and we will call the control system. Now let's talk about the advantages and disadvantages of robots. So the advantages of robots is that they can go away for faraway planets. They can go down into unknown waters and mines where humans would be in danger. It can also give information to humans that can't get, and it can work at places for 24/7 without any salary and food. Plus, they don't get bored. Moreover, they can perform tasks faster than humans and much more consistently and accurately. Most of them are automatic, so they can go around by themselves without any human interferences. Now the disadvantages. While robots can make people to lose jobs in factories, it also needs supply of power. It also needs maintenance to keep it running, and lastly, it costs money to make or buy a robot.